Alright, here's number 4. Um, train A runs back and forth on an east-west section of railroad track. A's velocity in meters per minute is given by a differentiable function v sub a of t for train A, where t is measured in minutes. Selected values for v of a is given in the table above. We want to find average acceleration. I'm kind of looking ahead. We're going to be find integral, trapezoid, second train B, and so forth. Okay, so find the average acceleration. Acceleration is the rate of change of the velocity. So A, the average acceleration on 2 to 8 is going to be equal to, I guess I'd probably just write this as VA of 8 minus VA of 2 over 8 minus 2. Probably the easiest way to just do that. Here, let me put my equal signs this way. Equals, and then the velocity at 8 is negative 120, minus the velocity at 2 is 100, over 8 minus 2 is 6, so that's negative 220, over 6, which is negative 110 over 3. Ooh, and then units. What are my units? Well, this is miles per minute per minute. So it's miles per minute squared. Okay. B. Okay, B is a great question for review because we haven't talked about this in our review, so this is good. Does the data support the conclusion that the train's velocity is negative 100 meters per minute at some time between 5 and 8? Well, at 5 it's going 40 meters per minute. At 8 it's going negative 120. So the negative, remember, just means it's turning around and going to the left. It's going 40 to the right at 5. It's going negative 120 to the left. And I know it's a differentiable function. It's a train. That means it's a smooth, the speed is smooth. Okay, there's no herky-jerky angle, sharp corners in the graph of the velocity or anything. It's continuous and everything. So if it goes from 40 to negative 120, doesn't it have to hit negative 100 sometime? And the answer is of course. What's the name of that theorem that tells you that? Yeah, it's the intermediate value theorem. Okay, so we can do this. And what are the conditions? Actually I can just say this. VA is continuous. That's the condition. Continuous since VA, let me be consistent with my writing here, A is differentiable. And I know that what is VA of 5? That's equal to 40. VA of 8 is negative 120. And clearly, negative 120 is less than negative 100 is less than 40. Okay, thus, by the intermediate value theorem, there is a t between 5 and 8. There's a value. There's a time t. Let's call this 5 less than t less than 8, such that VA of t equals negative 100. Okay, that's it. C. At time t equal 2, train A's position is 300 meters east of the Oregon station, and the train is moving to the east. Write an expression involving an integral that gives the position of the train in meters from the Oregon station at time t equal 12. Use a trapezoidal sub to estimate the approximate position of the train at 12. Well, let's write an integral that gives the position of the train at 12. Well, I know at 2 it's at 300. So the question is, where is the train from 2 to 12? Well, that's going to be its displacement, right? So from 2 to 12, isn't this right here going to represent the displacement? Let me write it out just so you can have it. Displacement of the train from t equal 2 to t equal 12, right? In other words, that's the net the net distance it goes from 2 to 12, not the total distance. So if I wanted to know where it's located at 12, then I have to take the 300, where it's located, from how far it is from the origin station. Well, I know it started at 300 meters, so I have to add the 300 to that. Okay, so 300, this is my initial starting place, plus where it changes to give me the total. Okay, so now it says to use it as, is that all right? Okay, think about what that means. Okay. So now I have to do this. It says to use a trapezoidal approximation here. And you can draw a quick sketch, or you can just kind of do it thinking about it. I like to make a sketch if I can, real quick, because it's less likely to make a mistake. 0, 2, 5, 8, and 12. 2 is up here at 100. Just make sure you mark everything, otherwise it might easy to mess up. 40. 8 is negative 120. And 12 is negative 150. So the trapezoid is going to be me connecting the dots and making the trapezoids. Oops. I love technology. Okay. Now this is kind of an interesting one right here. Okay, I don't know if you've ever really done one like that. Okay. So we've got this guy right here, area, plus this area, plus this kind of interesting thing. Well, we're still just going to go ahead and just go base 1 plus base 2, the average of the bases, times the height in between, and see what that ends up, and then figure out the area of that. Okay, and of course we're going to not forget to add the 300 to it. Okay, so we've got 300 plus, so it's approximately equal to, this guy right here is going to be 2 times the height is 100. Well, let me go ahead and just write it out. 1/2 times 2 times 100. Plus this trapezoid is 1/2. Add the bases together, 100 plus 40 times the height, 3. Plus 1/2. Add the bases together, 40 minus 120 plus a negative 120 times the height, 3. Plus 1/2. Add the bases together, negative 120 minus 150 times the distance between them, base is 4. Okay. And if I do all of that, which is a bit of a pain, but for the sake of time And again, you don't have a calculator, that you can cancel the 2's, and go that way and stuff. This is equal to negative 150. Okay. So what does that mean? Train A is approximately where? What does the negative mean? 150. Because was the question actually asking? Where's the position? Time equals 12. 150. We're talking meters. Which direction? West. So that's to the left of origin station. When t equals 12 minutes. Okay, there you go on that one. And now D. D's an interesting question, and it's worth 3 points of the 9. This problem here is worth 3. 1 for the position expression, 1 for the trapezoidal sum, and 1 for the position. 150 west. Now the interesting part is if you don't get this first part done up here, then you'll miss those 2 points because you won't get either one of those correct. So it's kind of a all or none sort of. Alright, D. D is kind of crazy, but then once you see it, you're going to go, that's okay, I can do that. A second train B travels north from the origin station at a time when the velocity is given by this at a time t equal 2. The train is 400 meters north of the station. Find the rate in meters per second at which the distance find the rate in meters per minute at which the distance between them is changing at time t equal 2. So I would draw a picture on this guy. Here's the origin. Go figure, they call it the origin station. So I'm going to go ahead and put this up here. And we've got train B traveling north, and it's 400 meters up here at 400 when t is equal to 2. It's going that way. And we have train A, this is B. We have train A, and train A was heading which way at 2? Train A was positioned as 300 meters east, and it's moving to the east. So train A was moving this way, and it's 300 when t equals 2. And I have a velocity, I know the velocity of A, and I know the velocity of B, because I have an equation for both, right? And what they're asking for D is what's the distance, what's the rate of change of the distance when t is equal to 2. So I'm interested in this guy right here. The rate of change of that guy. Okay. Rate of change of the distance. Okay, this is what someone else asked too, about, hey, can we have some practice on rate of change problems? Well, if you call this z, and this x, and this y, what we're trying to find is dz dt. Okay, well, how do I do that? Let's write an equation involving what we know. We know x squared plus y squared equals z squared. So if I take the derivative, 2x dx dt plus 2y dy dt equals 2z dz dt. Oops. And now I've got to try to figure out, okay, this is what we're looking for. Do you know everything else? Do you know what the rate of change, well, do you know what x is at when t equal 2? When t is 2, do you know what x is? Yeah, it's 300. Do you know what y is? Yeah, it's 400. Do you know what z is? Well, isn't that the 3, 4, 5 triangle? That's 500. If you don't know, you use the Pythagorean theorem. Do you know what dx dt is? The rate of change of the first train at 2. It doesn't tell us what it is, but can you find it? Or do can I figure out what it is? I know what the rate of change is. I've got an equation for v of b, so I could take the derivative and figure that one out. Do I know what the rate of change for the first one is? Somewhere on here. Well, let's start working this out and see what we got here. Okay, so let's go down here and see what we got. We got, when t is 2, we've got 2 times 300 times dx dt. Let's see, I'm not sure what that is yet, so let's kind of hold off on that. Plus 2 times y is 400 times dy dt equals 2 times 500 times dz dt. And let's figure out what we got with the best way to figure out dy dt and dx dt, which are the rate of change of my two trains. Okay, but we know exactly what they are. I don't know, I was making this harder than I thought it was. When we want it when t is equal to 2, what's the rate of change of train A? Well, right up here, it's 100. So train 2, that's x, or train A, that's 100. And B, they gave us the equation, so if you plug in 2 for B, you get 125. So we're going to do 125 here. Okay, that's what I get when I just plug it into, this is VB of 2, and this is VA of 2. Okay, that's the velocity, which is the rate of change. And now I solve for dz dt. So I'm going to go ahead and divide it to both sides to make it easier. And if I multiply these out and divide by 500, you get dz dt is equal to 160 meters per minute. Meters per minute. Okay, there you go on that one. Okay.